Hello students, in the previous class we have seen the RNS equations, and in that case we have seen the two methods. By using that methods we can calculate the energy of activation of reactant molecules. First method is integrations method and second method is graphical methods. By using both these methods we can calculate the energy of activations of any reactant molecule during the chemical reactions. Okay, so dear students, up to this I hope all of these things which I have covered in the previous video and the number of videos I will share with you. So I hope all of these three topics you may have noted down in your notebook and understand all these things. So today dear students, I am going to discuss some numerical problems related to the chemical kinetics, and which are very important for the exam point of view. So you have to note down all these problems and understand how to solve some numerical problem. Problem number first. So problem number first, write down in your notebook the rate constant. The rate constant. The rate constant of a reaction A 20 degree Celsius and 30 degree Celsius are 20 degree Celsius and 30 degree Celsius are 2.1 into 10 raised to minus 2 and 3.6 into 10 raised to minus 2 respectively. Full stop. Find out the energy of activations. Energy of activations. Energy of activations into bracket R is equal to 8.314 joule per mole per kg. This value of R is given into brackets. Some in your question paper, suppose questions may ask like that, and this value of R is given in your question paper. So this is the problems, and this problems is related to the energy of activations, because we have to find out the energy of activations of that reaction. Some reaction is considered here, and that consider reactions or imaginary reactions, and in that case we have to find out the energy of activations. So dear students, we have to know how to calculate the energy of activations by using integrations method. In that case we have discussed some formula related to how to calculate the energy of activations. So this formula that formula we have to use in this problem. So first of all, if suppose such type of questions asked in your exam, so your answer should be like that. So first you have to write the given data. Here the rate constant of reactions at 20 degrees Celsius and 30 degrees Celsius. At 20 and 30 degrees Celsius. So I am considering the value of T is 20 degrees Celsius. Value of T is 20 degrees Celsius, and because of this R value is given in Kelvin, so I wanted to convert this degree Celsius into Kelvin. So 0 degree Celsius means what? 273 Kelvin. So I will add into 20 plus 273 Kelvin, and whatever the value is after calculation. So this okay, and after that T2, I am considering T2 is 30 degrees Celsius. So I want to convert this 273 kV. Okay, so remember these things. Okay, so after calculations, I got the value of Kelvin, T1 temperature 293 Kelvin and 303 Kelvin. This is the after calculations of this 273 plus 30, 273 plus 20. So this is the after calculations I got this value in T1 and T2 in Kelvin. Okay, and next what is the given here? Rate constant. Rate constant, that is K1. K1 value of K1 is here 2.1 into 10 raised to minus 2. So I can write this value like that, 0.021. This value is equal to what? 2.2, 0.021. Because of this minus 2 is here. Minus 2 means 20 in front of this digit. So like that, value of K2 is given here 3.6 into 10 raised to minus 2. So I can write this value is like also 0.036, because minus 2 is here. Minus 2 means what? This value of, in front of this value there are two zeros. 0.0. Suppose I am writing this value is like just like that raised to 3. Then I will write this 0.10 is extra is here. 10 is extra like that. Okay, but in this problems 0.10 raised to minus 2 is there. Okay, and next given value is what? R. R value is given here 8.314 joule per mole per kg. 8.314 joule per mole per kg. Okay, up to this is the given data. On that base, on the basis of problems, I can write up to this, because this T1 value is given here, T2 value is given here, and K1 and K2 and R value is given in this problem. So you can write like that. And this, suppose these questions these questions may be asked for 3 marks. So 1 mark for this. Suppose you don't remember the formula, or you have to write in this question paper up to this, so you will get 1 mark. And now we have to write the next, how to calculate the energy of activations. So I know the formula, so we can write. We know that what we know that log of K2 upon K1 is equal to EA upon 2.303 R upon 3.30 R, and what? T2 minus T1 upon T1 into T2. This formula already we have covered in our previous video lectures. This formula comes from integrations method. So by using integrations method, by using this formula we can calculate the value of this energy of activations. We have to calculate this value, energy of activations. K2 value is we have know the K1 value, then this R value, and T2 and T1, the value of T1 and T2 is also we have to know. So by using this formula we can calculate the what? Energy of activation. So substitute the value of all these things in this formula. So I can write log of what? K2 is what? 0.036 upon K1 0.021 is equal to EA 2.303 into R 8.314 into 8.314 multiplied by T2. Value of T2 is what? 303 minus 293 divided by 293 into 303. Up to this I I hope all of these things you may have understand and note down your notebook. So we have to calculate this energy of activation. We have to calculate the energy of activation. So before going to directly convert this formula or directly calculate the energy of activation. So first of all, you have to solve these numericals. So log. If suppose I have solved these problems, then if when I solve this when I solve this problem, when I solve this numericals, and after solving I will take the log value, and so after taking the log value I will get the log value. For solving this 0.2340 is equal to value of EA as it is, and after multiplying these two values I will get the 190.1471 multiply by what? 10 upon 779. Okay, up to this I have solved. So now I want to solve some 240 is equal to EA upon 19.1471 multiply by, after dividing this 10 divide by this value, so I will get the value 0.001126. Okay, up to this solving I can rearrange these equations, like, because I wanted to find out the energy of activation. So and up to this, and I will convert this formula like that. Energy of activations can be calculated by using simple multiplication is there. 19.1471 multiplied by 0.0000, sorry 30 is here, 1126 divided by 0.2340. After the calculations of this value, I will get the energy of activation, that is EA is equal to 0.00926 Joule per mole. This is the final value of the problem, and we have calculated the energy of activations of these reactions. So this is 1 mark, this you will get 1 mark, and this you will get 1 mark. This is all these problems. If you solve like that, then you will get 3 marks. Okay, so this is the first problem related to the energy of activations and how to calculate the energy of activations of any reactions. So such type of problems may be asked in your exam, so you have to solve and write in your answer sheet like that. Okay, so I hope all of you may have understand and note down your notebook. So this is very simple and easy problems, so you may be able to write in your answer sheet. Now we will solve the next problem related to energy of activations. So problem number 2, a plot of ln k versus 1 upon t give a straight line of which the slope minus 1.2 into 10 raised to 4 k. Full stop. Is the what is the activation energy? Activation energy. Activation energy of the reactions into bracket R is equal to 8.314 joule per mole per kilo. The value of R is given here. R is what? Molar gas constants. You have seen the type equation T is equal to nRT. T is equal to nRT. This is the ideal gas equations, and in that case, this pressure, volume, this N is number of moles, T is temperature, and this R is what? Molar gas constants. You have already seen all these things, so I am not discussing all these things. So value of R, that is the molar gas constants given is there. So such type of problem, suppose ask you in the exam, so you have to write like that. First you have to write the given data. What is given here? ln k versus what? Those there is by using graphical methods we can calculate the energy of activations. In the previous problems we have seen the by using integrations methods we can calculate the energy of activations, and in these problems we can calculate the energy of activations by using graphical methods, because in this the graph is given and the value of straight line, the slope value is given here. So this is the related to the what? Graphical method. So we can calculate this. So we can write this slope value is what? Minus 1.2 into 10 raised to 4 k. The R value of R is equal to 8.314 joule per mole per k. Joule per mole per kilo. Okay. So if you remember, in the previous video we have deal with the graphical method. In that case we know that in that case we have discussed the formula related to how to calculate the energy of activations. So we know that, and that formula you have to remember. And in that formula is like that: slope is equal to minus EA upon R. Minus EA upon R. On the basis of graphical method, this is the formula. In this, the value of slope is given, value of R is given here. We have to find out the what? Energy of activation. So this is the formula. So I know the value of slope is what? Minus 1 point into 10 raised to 4 is equal to minus EA, and the value of R is what? 8.314. The value of R is given here. So up to this I can write like that. Okay. So I wanted to solve this. I wanted to find out the energy of activation. So the energy of activations, I find for finding the energy of activations, I will rearrange these equations like that. Minus 1.2 into 10 raised to what? Minus 4 into minus 8314. Minus 8314, because this minus sign is here. Minus sign is in formula, that's why this value is what? Minus. So after calculating all these things, I will get the final answer in positive, because minus minus get cancelled. So 0.1.0 into 10 raised to what? 5 joule per mole. This is the final answer of your problem. So by using graphical methods and by using integration methods, we have discussed 2 problems, and I hope all these problems you have noted down in your notebook, and if you have any queries related to this problem, your notebook. So this is your this problem is very important. Problem number 3. This is for homework. This is for homework. You have to solve, or you have to what? Write down in your notebook. Problem number 3. 550 degrees Celsius, comma, the rate of the write down these problems in your notebook because I am giving to you homework. So the rate constant for the reaction, comma, reaction is given here, CH4 gaseous state plus 2H2 gaseous state, sulfur gaseous state gives product carbon disulfide gaseous state plus 2 molecules of hydrogen sulfate gases. Okay, this is the chemical reactions given. Okay, so this chemical reaction state with 560 degrees Celsius, the rate constant for the reactions is 1.1 liter per mole second and 625 degrees Celsius, the rate constant is 6.4, just a minute, 6.4, okay, 6.4 liter per mole second, full stop. Calculate the energy of activations for the reactions, question mark, and given is R value is given here. So 8.314 joule per mole per kg. This is the value of R given is here. So the value of K1, K2 value is given here, T1 and T2 value is given in this formula, and we have to calculate the energy of activations. I hope you may able to find out the value of energy activations of their problems and write down and solve these problems. If you are not solved, or if you have problem in this numericals, then you can contact me and I will solve the, if you are not able, then I will solve these problems. Okay, but you have to try it and try for the solving of this numerical problems. So dear students, this up to this we have covered all the topics related to the chemical kinetics, and this is the end of our first chapter, that is chemical kinetics, and I will tell you how to which questions are very important for the exam point of view, and how to remember all these things, because we have covered already the zero order reactions, third order reactions, what are the factors which affecting the rate of reactions, and how to write the rate of any chemical reactions, how to find out the order and molecularity of the reactions, difference between the order and molecularity. We have already covered all these things, and Arrhenius equations, and by using Arrhenius equation how to find out the energy of activation. There are two methods. First one is integrations method, second one is graphical methods. So up to this chemical kinetics I have covered. You may have understand and note down your notebooks. So this is the end of our first chapter, that is chemical kinetics. Okay, so be ready for the exam, or so be ready for the exam, or be ready for the your future careers. If suppose some this chemical kinetics questions may be asked